This video is going to run through a brief overview of working with linear functions. A linear function is of the form f of x equals mx plus b. In the past, you might have seen this written as y equals mx plus b. That's the equation of a line in slope-intercept form. I'm just using function notation, replacing the y with an f of x. In a linear function, the m, the number in front of the x, is the slope. Slope is a rate of change, and you compute it by taking the rise over run, or change in y over change in x. The b is the y-intercept of that line. It's the place where x equals 0. So let's run through some examples. We'll start by graphing. If we want to graph the linear function f of x equals negative 2x plus 3, this function is in slope-intercept form. The slope is the number in front of the x, negative 2, or negative 2 over 1, and the b, or the y-intercept, is 3. So to create the graph, I'm going to start by plotting that y-intercept. So when x is 0, y is 3. Then I can use the slope to finish drawing my graph. If the slope is negative 2, or negative 2 over 1, that means I would go down 2 over 1. And I can repeat that process, down 2 over 1, and then eventually connect the dots. And there's a graph of this linear function. Now, linear functions will either be increasing, that occurs when you have a positive slope, decreasing, that happens anytime the slope is negative, or finally we can have a constant linear function, and that would be our horizontal lines, or when the slope is equal to 0. So in the example we just did, this is an example of a decreasing function. That slope or rate of change is negative 2, and you can visually see that as you go from left to right, the y values are decreasing or getting smaller. All right, so here's another example. Let's write an equation of the function shown. We have a linear function drawn. It's a line. This line is decreasing. It's going down. So without doing any work, I know that its slope has to be negative. I can compute the slope by picking any 2 points on this line, and I can see that the y-intercept is at 5, 0, 5, and then actually there's my x-intercept at 4, 0. So that means the slope would be rise over run, so we have to go down 4, no, sorry, I said that wrong, down 5 over 4. So that means my slope is negative 5 divided by 4, rise over run. And again, notice that slope is negative because we have a decreasing function. I can also see on the graph that my y-intercept, or the b, is at 5. So that makes my function f of x equals negative 5/4 x plus 5. Here's another example. Write the equation of a linear function such that f of 2 equals 3 and f of negative 1 equals 4. So technically we're given 2 points on this line, just in function notation. F of 2 equals 3 means that when x is 2, the y value is 3. F of negative 1 equals 4 means when the input x is negative 1, the output, or y, is 4. So I can compute my slope by taking change in y, so 4 minus 3, divided by change in x, negative 1 minus 2. That's 1 over negative 3, or negative 1/3. Now there's a couple different ways we can get the equation of our line. My preferred method is using something called the point-slope formula. The point-slope formula basically tells us that the rise, the change in y, equals the slope times the run. It's just our slope formula written a little bit differently. And with that point-slope formula, you need to know the slope, which we just computed, and then you can plug in any point for the x1, y1. So using this formula, I'm going to take the negative 1/3, that gets plugged in for m, and then I'm going to use the point 2, 3 as my x1, y1. So this becomes y minus 3 equals negative 1/3 x minus 2. If I want to put this in the slope-intercept form, if I want to solve this for y, I can distribute the negative 1/3. So y minus 3 equals negative 1/3 x, and then plus 2/3. Then I'm going to add 3 to both sides. 2 over 3 plus 3 over 1, get a common denominator. That becomes 2 over 3 plus 9 over 3, or 11/3. And my equation is y equals negative 1/3 x plus 11/3. Or if I want to use function notation, that would be f of x equals negative 1/3 x plus 11/3. Okay, my next example says find the equation of a linear function that is perpendicular to f of x equals 2x plus 5 and passes through the point 2, 5. So first, I'm going to define perpendicular. Perpendicular lines are lines that cross at a right angle or a 90-degree angle. Perpendicular lines have slopes that are negative reciprocals. That means that the slope of one line, for example, if the slope of one line is 2/3, then a line perpendicular to it would have a slope that is negative 3/2. So perpendicular lines have slopes with opposite signs, and then reciprocals just means you flip the fraction. All right, while we're talking about relationships between lines, I should probably define parallel lines. Parallel lines have the same slope, and they never intersect. All right, so back to the problem we're trying to do. We're trying to find the equation of a linear function that is perpendicular to the function given. The equation given, f of x equals 2x plus 5, has a slope of 2. So a line that is perpendicular to that would have a slope of negative 1/2. Again, this is like a 2 over 1, so I flip it, it becomes a 1/2, and I make it negative. All right, so I know the slope, and I know a point, the point 2, 5. So once again, I can use that point slope formula. I'm going to take my slope, which is negative 1/2, plug that in for m, and then because the line goes through the point 2, 5, I can put 2 in for x1 and 5 in for y1. So that gives me y minus 5 equals negative 1/2 times x minus 2. I'm going to solve this for y. I'm going to distribute the negative 1/2. So y minus 5 equals negative 1/2 x. And then minus 1/2 times minus 2 becomes plus 1. It's a 2 over 2 or a 1. Finally, add 5 to both sides, and I'm left with y equals negative 1/2 x plus 6. Or in function notation, f of x equals negative 1/2 x plus 6. All right, let's run through a couple of application problems. My first application problem says a phone company charges for service according to the formula C of n equals 24 plus 0.1 n, where n is number of minutes talked, and C of n is the monthly charge in dollars. Find and interpret the rate of change and the initial value. So rate of change is referring to the slope. Slope is a rate of change. The initial value of the function is referring to that y-intercept. So the function they gave us, C of n equals 24 plus 0.1 n, has a slope of 0.1. That's the number in front of the variable. They used n's instead of x's, but same idea. So the slope is 0.1. And the y-intercept, or initial value, is the constant, or 24. To interpret your slope, you can think about the units. Slope is defined to be change in y divided by change in x. So in this problem, the y values, or the outputs, is your monthly charge in dollars. And the x values, in this case they call them n, is number of minutes talked. So this slope is giving me a charge, dollars, per number of minutes talked. Or in other words, 10 cents or $0.1 is charged per minute talked. So the slope, or the rate of change, is telling me the rate that we're charged at per minute. So we're charged 10 cents a minute. The y-intercept, or the initial value, tells us what happens when we plug 0 into the function. So when n is 0, that means 0 minutes have been talked. So after 0 minutes, our cost is $24. In this case, that $24 is an initial cost, or you could call it a fixed monthly charge. So with this particular function, we know that we are always being charged $24. That's our fixed cost. And then on top of that, we are charged 10 cents per minute. All right, let's do one more application problem. My last example says, a clothing business finds that there is a linear relationship between number of shirts, N, it can sell, and the price, P, it can charge per shirt. In particular, data shows that 1,000 shirts can be sold at a price of $30, while 3,000 shirts can be sold at a price of $22. Find a linear equation of the form P of N equals Mn plus B that gives the price they can charge for N shirts. So we're writing a linear function, and they're actually giving us 2 points. They're telling us that when N is 1,000, P of 1,000, or the price for 1,000 shirts, is $30. P of 3,000 is $22. We can use this information to find our slope by taking change in y, 22 minus 30, divided by change in x, 30 minus 1,000. That gives me negative 8 over 2,000, or if I reduce that, negative 1 over 250. So there's my slope. Then I can use that point slope formula. I'm going to plug the negative 1 over 250 in for my slope. And then I'll use this point P of 1,000 equals 30, so I'll plug 1,000 in for the x1 and 30 in for the y1. So y minus 30 equals negative 1 over 250 times x minus 1,000. If I distribute the negative 1 over 250, I get y minus 30 equals negative 1 over 250x plus 4. So I took that 1 over 250 times 1,000, that's where I got the 4. Then I add 30 to both sides. Y equals negative 1 over 250x plus 34. That's my linear function. To finish, I should use the letters they gave me in the problem. Let's see. Instead of x, there we go. Instead of x, they're using n. And instead of y, we're using p of n. So my function is P of n equals negative 1 over 250n plus 34. And this is a function that gives me the relationship between price and the number of shirts that I can sell. Sometimes we refer to this as our demand function. They don't ask us to interpret, but what these numbers are telling us, that 34 is our initial value, or our y-intercept. So that's telling us when n is 0, P is 34. So in other words, if they charge $34 a shirt, no shirts will be sold. The demand will be 0. The slope is negative, and that's giving us the information that if they decrease the price, more shirts will be sold. And that tells us how much do we have to decrease the price for every increase in demand for shirts. All right, that was my last example. This was a quick overview of linear functions. So please reach out if anything in this video is unclear.